Welcome back. So we started 2 lectures ago with neural networks, and the last lecture, reinforcement learning in continuous spaces, we found neural Q-learning. Basically, it is predicated on this update rule. First of all, it is predicated on we are basically replacing Q table with this neural network estimate. We discussed how to choose this basis using action separation, and theta is obtained iteratively using this theta update rule. We discussed all these in detail, but I didn't present it you neural learning algorithm step by step, right? If you are coding it yourself, there is a specific structure like you saw in the Q-learning video, Q-iteration videos. So this is, first of all, as discussed, this is an off-policy reinforcement learning method. You can also use an on-policy reinforcement learning method like the SARSA. So yeah, I mean, the purpose of this video is twofold. First, I would like to present the algorithmic structure of the neural learning algorithm, and then as a popular on-policy method, I'm going to show you neural SARSA. Again, what SARSA stands for: state, action, reward, state, action. You basically take the state value, make an action, observe the reward, and using that reward and the new state, take action again, actually. So remember, right, SARSA learns from the actual moves it makes, whether they are good or bad, and as compared to Q-learning, it can converge slower. We discussed this, but in the long run, it can be more stable. I personally use Q-learning and SARSA all the time, so they are both excellent candidates. And the only difference is here. Here, basically, right, when you code this, it looks the row of, basically, it looks at max Q transpose S prime. You look at the action with the maximum value here. Here, no, you do an action, you put this action back here and get the estimate. Again, it learns from the actual moves. And I'm going to present, if you know, it works really similar to the SARSA video, but I will re-explain everything. First, let me start with neural Q-learning algorithm. In the actual Q-learning, we were initializing the Q values. Here, the theta values. You can choose it to be all zeros. Actually, in the MATLAB one, sometimes I choose to be random to spice things up. It can increase sometimes convergence a little bit, or you can start a little bit better instead of everything is zero. But if you are not familiar, you can perfectly select them to be all zeros. Then take an action, and here, if you remember, we take an optimal action with 1 minus epsilon probability, and otherwise a random action with some, you can say it like 10% and 90%. And then you apply your action to the environment and measure the S prime. I'm going to use the similar example. You apply an action to the robot, it moves to the left, and its state change from 1 meter to 1.5 meters, say, so your S prime becomes that number. And then you update theta for S and A, and again here you don't need to know A prime, I just explained. You just look at the S prime row of this Q and phi and choose the maximum one. So this is the exactly the theta update rule. We are not updating state 1, state 2, state 3. We don't have a table. Everything is continuous now. We are updating the theta. Your state can be 1.5, 2.5. It doesn't matter. Exact discretization 1, 2, 3, 4 doesn't matter anymore. And after you update the theta, basically you turn back to step 2 until convergence or the end of all episodes if you have some terminal states that ends the game in the iteration. And finally, after you repeat this, you extract optimal policy using argmax A. Previously we were using the Q table here. We no longer have it, so we are going to use its approximation to extract the optimal policy. Let's look at the neural SARSA algorithm. The pink steps are identical steps to Q-learning, and green steps are the different steps. We initialize theta, take an action. We apply that action to the environment, and we get state and rewards. Then, basically, with the S prime we get, we take action and we find A prime. So A prime either with, again, similar to this, with some probability optimal A prime, with some probability random A prime. And once we get A prime, now here we need A prime. It is just not a row of S prime. So we remove this max here if you compare to here. We are not maximizing anything. We are using exact S prime and A prime here and do this iteration for theta. And then, as I said, you turn back to step 2, wait until converges or till the end of all episodes. And once done, you extract optimal policy using the similar argmax equals same argmax basis transpose multiplied by the theta vector. All right, so in the next video we are going to do a MATLAB study both for neural Q-learning and neural SARSA. So after that, I am going to introduce you some other technique to improve the learning process of these neural networks, but I am probably either do it for reinforcement learning like neural Q-learning or neural Q-SARSA. You can always, and I am going to provide the 2 codes. So again, the only difference that you replace this step with this, and in the next class when you see the MATLAB example, I will provide you the codes for both. So if you want to try what I'm going to show you, this so-called experience replay. If I may show it just on the reinforcement learning neural Q-learning, not necessarily for neural SARSA, but you can try yourselves. All right, take care.